So, here is my very simple Kivy tutorial, hopefully the first in at least a small series, showing how to build a simple Kivy app, how a basic Kivy program works, and how to build it for Android. Even a very simple Kivy app can very easily be made cross-platform. Now, just in case anyone doesn't know, Kivy is a graphical framework for Python. You use it to make user interfaces, and it comes with a nice set of highly extensible widgets to easily get very complex behavior. One of the really big advantages of Kivy is it's highly cross-platform. That doesn't just mean you can run your Kivy app on Windows, Linux or OS X, although you can, but also on Android and iOS, plus more unusual devices like the Raspberry Pi. I'm not going to introduce Kivy itself much. You'll need to have it already installed if you want to follow along, but I won't assume any existing knowledge of how it works. You'll also need to know a little Python to fully understand some of the details, but again it shouldn't be a problem just to follow along with what I'm doing. So, we want to make a Kivy app. Our entry point is going to be an app class. That means from kivy.app we import app. Now the app is the base of any Kivy application. We're going to run it by creating an app. Let's call it tutorial app. And it doesn't even need to do anything. We've just created a simple subclass that's going to be our Kivy program. What the app does is, when run, initializes everything Kivy needs. It does any interaction with the system, creates a window, sizes the window, and so on. And it can even do things like create a default settings panel if you wanted to. We don't need to do any of that to start with. We'll just create a totally trivial one and use a standard from Python if name equals main tutorial app, create an instance and run it. Run is the method that tells the app to start and to do its thing. And that's it to start with. We can hopefully do this app. We can run it. Python tutorial.py, and it works. We get a totally blank Kivy window, but the app's initialized fine. It exists. Now all we need to do is tell it how to actually display anything. In practice for Kivy, this means telling it to display some widget. Kivy comes with quite a lot of widgets, generally small with a small amount of behavior of their own. You have a button that just has a simple ability to click and hold. Then checkboxes, other widgets that lay out other widgets. But then adding them together, which is very easy, you can create much more complex interfaces with any behavior you like. For now, we'll just use a simple button from Kivy the button, import button. And we need to tell Kivy how to display this button. We do this using the build method of app. When the app is run, it calls this build method, and whatever build returned is going to be our root widget, the top level one. Kivy is going to put that in the window, it'll resize it to fill the window, and anything else our application has, any other interface, has to be a sub widget of that one. For now, ours is just simple. We return our button. We can give it some text. Text equals hello. We can set the background color if we like. This is RGBA, so let's make it blue, not 1. And let's set the font size to something a little larger. 150 pixels. Usually it would be fine, but just for this example video, it would be easier to see. And that's it. Now when the app runs, it's going to do everything it already did, but it's also going to call this build method. It's going to take this button and it's going to fill the window with it as our app's interface. So let's do it. Tutorial. There we are. Our button. We can click the button. It goes brighter. We can click and hold. And if we wanted to, we could bind behavior to all these things, cause clicking the button to do anything we like, really. As a simple Kivy app, I would stop there. Already we have everything we need to make a fully working app. You can change the button properties, you can change the text, the background color, the font size. If you check the Kivy website, I'll put a link in the description of the video, you can see what other properties the button has. You can change its background image when pressed or when not pressed, or you could even replace it with different widgets. Simple ones like a label or a checkbox won't require any significant change from what's here, but already make the program look very different. Rather than actually stopping the video here, I'm going to cover a little more behavior and some more complex interaction with a Kivy scatter widget. This is going to let us have something very similar to what we already have, but we're going to get some fancy touch behavior, moving, rotation and scaling, without putting any effort in at all, just by using the right Kivy widget. We'll import our scatter. The scatter is the widget that knows how to do all this. It tracks the touches, it knows how to make things bigger and smaller and to rotate them. We won't need our button, but let's replace it with a label, and we'll need some layout to put everything in. It's going to be replace the top level root widget. We'll just use a simple float layout. Now this works essentially like your desktop probably does. Every widget, or every window if it was your desktop, has its own size and position. What the float layout gives us is the ability to describe all this proportionally, so your app would work fine on any different resolution or size of device. Though we don't need any of that behavior right now. Now instead of making a button, we'll need to make a float layout. No special behavior, just the default float layout. We'll make a scatter. Again, nothing special. Scatter already knows how to do all the interaction we want. Although if we wanted, we could disable things like scaling or rotation at this point. And let's replace our button with a label instead. The label doesn't have a background color. We'll give it a text and a font size still. Now we have 3 widgets. This is different to before, where we only had a button. We can only return one of them. It's going to be the root widget, so the others will have to be children. We do that by adding each widget to one above it. Add to the float layout as a scatter. We could add any number of widgets to the float layout, but we only have one here. And we'll add to the scatter our label. So now everything is below the float layout. We can return that and see what happens. There we are. So now we don't have the button anymore, we don't have any colour. We have our label saying hello, but in the bottom left here, that's the default position of a new widget, and we didn't set that. But because it's a scatter, now we can click and move it. We didn't do anything special to make this happen. Scatter already knows how to handle the touch, how to handle the movement. If I had a multi-touch monitor, which I only wish I did, we could interact with the scatter in other ways. We could pinch to zoom or to rotate. And in fact, Kivy, the desktop version, includes some simple multi-touch emulation if I right-click twice. Now I can not that. Now I can drag around these two touch emulation dots, and I can get exactly this behavior. Again, I didn't tell anything how to rotate or how to move or how to scale, but the scatter handles it all for us. And it could keep doing that even if it wasn't hello. It could be any set of buttons or the full UI of your app. It could be rotated trivially just by adding it to a scatter. Now I will stop there. Again, it's a simple Kivy app, and you can experiment with this as you like. Perhaps you could replace the label with an image. Again, you'd get the touch rotation for free. Or replace the float layout with a different layout to see how different Kivy widgets behave. For my next video, I think I'd take this app and show you already how to compile it for Android. Without doing anything special, we haven't put any Android specific behavior in, but already we can make it an Android APK, upload it to our device, interact with it with a touch interface rather than the simple mouse one. But that's for the next video. Thank you for watching.